Welcome to Evolution in Controls. I'm Tim Wilson, your host. Whether this is your first time joining us or you're a returning viewer, thank you for taking the time and spending it with us. Our topic for today is a very current and hot topic. It's about some new and upcoming technology that's being applied to what many would consider a long, standard, basic feature in most manufacturing environments. The new technology I'm talking about is IoT, the Internet of Things. And we hear all the time about how it's going to revolutionize our kitchen or our toaster or our fridge and the groceries we really need to buy. But what is it really going to do in the manufacturing environment? There are a lot of promises being made about the upcoming benefits, but what can it do for the lowly hydraulic power unit? According to a recent Deloitte study, unplanned maintenance costs manufacturers $50 billion each year, and poor maintenance strategies starting from a lack of information cost 5 to 20% of a plant's overall efficiency. So to talk about IoT's promise of delivering real-time condition monitoring and how it applies to a hydraulic power unit, we've got a special guest. Mr. Mark Garrett is president and one of the owners of Morel, but more importantly, Mark has been dealing with hydraulic power units for all of his 25 years of service at Morel. Mark, thank you for joining us.
Thank you, Tim.
So, how long have you been with Morel?
So this is 24 years this year in October.
Okay. And had you had a hydraulic background before you came?
I did. I was working for a hydraulics company out on the East Coast for about 4 years, and I came from the shipping industry, and we had hydraulics in our steering gear and certain critical functions. So I had some background, but not a lot.
Okay. So do you think that any of the power units that you worked on when you first got here, are they still running?
They probably are. I would say in the ships they're still running. Some of the early units that we did in the steel mills are still running.
Okay.
Kind of like you, Tim. You're still running.
I doubt that there's any power units as old as me still in operation.
I would guess not.
So, take a hydraulic power unit. What has changed over the last 25, 30 years?
Thanks, Tim. I think the core of the hydraulic units, from my experience, hasn't changed substantially in 25 years. So just, it's a tank, it's a reservoir, it's a pump, it's a motor, it's a filter. But outside of that, I think the changes that we've seen over the last few years have been more in, engineering and more around this IoT, as you mentioned earlier. So customers are wanting to see what's going on with the power unit, more details, more predictive maintenance. Let's do maintenance on the unit before things fail so we know what's happening. So I think that's kind of where the technology has changed over the last few years.
So you're not actually improving the basic components of the power unit, but
Correct.
You're watching what they do more closely?
Correct. We're monitoring fluid life. So instead of just routinely changing fluid in a power unit, in many cases with filtration technology today, that new fluid may be worse than the current fluid that's in there. It may be more contaminated. It may have issues that you induce just by changing, where if we can monitor it and know that it's still in good condition. So we do that with a few different ways. HYDAC has some tools available for fluid monitoring where we can monitor, water content is a contaminant. And so we can not
just metal chips.
Correct. So we can monitor moisture content to see if there's water building up that we need to either remove it or change the fluid, but we also monitor particle counts. But now today, HYDAC has a product called a HYDAC Lab that actually monitors the fluid condition. So we're watching viscosity levels, acidity levels, and we can kind of watch predictively what's going on with the fluids. The other side of it is really starting to watch what's going on with the pumps or the electric motors. Vibration analysis is one way. Really trying to do predictive wear on these components and try to change them in planned maintenance outages rather than having
What's going to cause
machine
the
go
pump?
down.
What's going to cause the pump to vibrate? Why vibration analysis?
So everything has a bearing. The bearings all have a life, a B10 life, and so after a certain amount of time, those bearings will start to wear, and we can monitor those. Or if there has been an issue with the fluids and it's starting to cause a bearing breakdown, that we can monitor that and know what's going on before it happens. Historically, on the power units, the failures were always, let's say, instantaneous and causing machine downtime. Now we try to watch and say, hey, this may be coming. Let's plan around it.
So IoT is going to communicate the information. So there's sensors that we then
Correct.
would put on the power unit.
Correct.
So you mentioned fluid condition, you mentioned water, you mentioned contamination, vibration, anything else that we're monitoring?
Yeah, along the vibration side, just to provide a little more details there, Bosch Rexroth has some small, almost, slightly larger than a computer chip size sensors that we can put on their XDK sensors that will measure that vibration through accelerometers, etc. So that's a good way to monitor the bearing life with the Bosch Rexroth sensor. We'll also monitor K-strain leakage on the pumps, which is really a predictive way to watch for wear. So as that pump starts to wear internally, not just on the bearing side, but more on the internal component side, the leakage goes up. We can monitor that. We can give a customer, hey, as long as you stay within this range, you're okay. But if you start to fall outside of this leakage range, you should probably start looking at having the pump sent out for us to take a look at it or do a repair.
Okay, so there's sensors on the power unit. They use IoT, Internet of Things, to communicate that. Where does the information go?
So we combine all that back into typically either a module that will send that off back to either the plant's main computer system for monitoring, or to the cloud. There's a lot of cloud-based services today that we can offer, or most of our customers want to monitor that themselves, so we'll help them set that service up to monitor it. But a lot of them are running it back through the machine control. So they're running it back in, sending that information. We compile it, send it back in through the PLC on the machine level control, and they monitor it that way. But you can do it now with your phones. You can do it with your iPads or tablets. Most of those sensors, the critical ones we have set up now, where it'll send you a text, it'll call your phone.
So I get an alert on my phone.
Right.
Hey, the fluid is dirty. Hey, the pump's vibrating.
Sure. Filter needs to be changed. Something's happened with the pump. But a lot of it's, if everything's going as planned, a lot of it we're watching trending. We're not waiting for some catastrophic failure to happen. We're really watching trending and saying, hey, this may be starting to hit a point that we should take a look at it.
And so that's the difference, because I know that you've had pop-up indicators on filters saying that they're dirty. You've had other sensors on contamination. You've had other things that would tell a maintenance person from a visual inspection, but that's at the point when it needs to be done now.
Correct.
So this is saying, hey, the trend is headed in a downward direction.
Right. It's all about that predictive, where are we headed, and can we plan around it? And it just provides uptime. Now the machines can be serviced when you want to, not when you have to.
Do you find that the users of these power units, are they actually making good use of this data, or is it just more data that they
We're seeing it increase a lot recently. So the larger users, the big steel mills, where downtime is very critical, very costly, we're seeing them use this data and want this data on pretty much every unit that we do now. So it's really a growing trend. We kind of heard this IoT or Industry 4.0, and it was kind of these buzzwords, but what did they really mean? But now we're kind of drilling down to what does the customer really want to see? How do they want to see it? And is it useful? And I think we've kind of narrowed that down to providing very useful information to them.
So it's not just technology looking for a problem. It really is a problem that they're looking for technology to help solve it.
Correct.
Okay. So what role does Morel play in this new development?
So really it's collaborating with the customer to say, what do you want to, what is critical to you? Some people, maybe downtime isn't as critical, or that investment is more than, or to do the full IoT investment maybe is more than they want to do on these units. But our job really is to sit down and listen to the customer. What are you looking for? What is important to you? Is it downtime? Is it this? Is it fluid cost? Some of these fluids are very expensive. So if we can monitor fluid life and say, hey, don't change the fluid when you don't have to, and it will save you tens of thousands of dollars, those are all, quick returns on that investment. So we sit down with the customers, ask what's important to them, and then help with the sensor selection. What is important? Let's put the bearing sensors on. Let's put K-strain monitoring on. Let's put a HIDAC lab on to watch fluid condition monitoring. So we'll listen to that. We'll help with the sensor selection and then kind of put that whole package together for them as part of the. So instead of just doing the mechanical build today, we're really seeing that we're also doing this whole controls build on the power units at the same time.
Okay. So our partners in this are Bosch, Rexroth, and Heideck. You mentioned them
Correct.
earlier. What do they see coming in the future? What do they see the future looking like?
I think the sensor development is really growing, it's really expanding of what can they monitor, what can they see. I think tying together, you can watch on pumps, you can start to monitor swivel angle and see that, hey, we used to be at a certain, let's say, swivel angle or flow to provide that flow, and now it's having to go further, meaning that the pump's probably wearing further. So, there's just more and more data that we can start to collect and really kind of put that whole puzzle together of what's going on.
So the whole controls architecture is going to have to keep up with the changes in the sensors and the information that's coming back from them.
Correct. And how to best apply them and what data can they really provide that's useful.
So maybe in the future, a power unit that you sell could last as long as either you or I have been working.
Maybe too.
Mark, we're running out of time. I want to thank you for joining us today and taking the time to talk to us. Very fascinating.
Thanks, Tim.
And thank you for joining us.